Alrighty guys, we are going to continue taking notes, and what I want to talk about with you today on pages 42 and 43 is function notation. So a way to represent a function is, through a table, through a graph, through ordered pairs, things like that. But really another way to represent a function is kind of with an equation. So like we were talking about before, like when you have an x in there, but also we have y. So kind of there are two variables, like you maybe remember from last year, y equals mx plus b. That is a function. So we're going to take a look at specific function notation. So on page 42, we have this one here, which we're going to take a look at second. And then we're going to start on page 43 right here. So we really want to think of a function as a machine that does something, okay? So a function can be thought of as a machine, kind of like your wash machine. You know, like you put clothes in, you put dirty clothes in, you clean clothes out, okay? So a function can be thought of as a machine that assigns one x value to each y value. Okay, and we showed this, previously with like our mapping function or our mapping diagrams, where I'm saying, okay, this x value is assigned to this y value. So it's giving 1x to 1y. Unlike this one, where this was giving like 1x to 2y's. That's not a function. Okay, now this is how we represent it with an equation. So you'll notice over here, this is kind of what the equation does, or like how the machine works. So what the function does. So this function specifically takes a number, multiplies by 3, and then adds 4. So that's what this function does. So times by 3, then add 4. Other functions will do other things. That's what this one does. So then we have this stuff on the other side here, which is just kind of how we name the function. Like, you don't need to worry about this too much, but it is handy to have all this because it tells us a lot of information. So the letter in front of the parentheses is just the name of the function. So like, I have a name, Marissa, you have a name. It's so that we can tell the difference between different types of functions. So this function's name is f. So this is just the name of our function. And then inside the parentheses, we're showing what number we're going to input into the function. So what number are we putting in to the machine? So again, if we think about a wash machine, this is where I'd show, okay, I'm putting in dirty clothes, and I'm going to get out clean clothes, okay? So the x value that goes into my function. I get lazy with function. Sometimes I just put fn. So kind of your input value. Now all this over here together is really considered your output. It's like the y value that comes out after the fact. So, which I know can be kind of confusing, but it's just another way to write the y value or your output. So we use this function notation to express a lot of information all at once. I'm talking about what the function's called. I'm showing what I input into the function. We're showing what the function does, and then what do I get out of the function. So again, if we kind of think of it like a machine, say these are our little machines down here, Again, this function up here multiplies by 3, adds 4. So if we think about this, if I were to take f of 2, this is showing me that I'm going to put 2 into my function. So it is being put in place of x. So 2 is kind of your x value. And so when I put it in, what this function does is multiplies by 3 and then adds 4. And so if I do that, I get 10. So when we write this out, we would show that f of 2 equals 10, which is super nice because, again, that's a lot of information. I get to see my input value and my output value. So my x value was 2. My y value is 10. So I can really write it as an ordered pair to see like x comma y. So that's super nice. Another example of that could be if we have -1 going into the function. This function here multiplies by 3, adds 4. And so if I multiply by 3 and then add 4, I get out 1. And again, if I were to write this out, I would see that when I put -1 into my f function, I got out 1. So if I wanted to write it as an ordered pair, I have that in place of x, I had -1, and then that -1 is assigned to this y value of 1. Alrighty, so on the inside here, we just got a bunch of different ones to try. So here we have our f function, which is going to square your number and then add 3. Then I have the g function, which just adds 1. So when we're going to write these out, first of all, I need to notice which function should I be looking at. So for this one here, I'm looking at the f function, which is going to take that number that I'm inputting and square it, and then add 3. So if we simplify that by following order of operations, 3 squared is 9, plus 3 more is 12. So I could write this as an ordered pair, 3 comma 12, because I input 3, got out 12. This one, we're doing g of 3. So I need to go look at my g function, which adds 1. So when I put in 3, I'm going to add 1. And so g of 3 is 4. Next one, if we got f of -2, this is showing me that I'm going to input -2 into my f function, which is going to square that and then add 3. So -2 squared is 4. Plus 3 is 7. And guys, it's okay to show your work. Like, I know I'm not, but you could show your work there. So like this would turn into 4 plus 3, which is 7. The important thing to realize though is like, I'm not solving for f. That's not a thing that we're doing. This is simply showing me that when I input -2, I get out 7. So it gets us our x and our y value, okay? So another example of this could be if I'm going to input 0 into the g function, I would pick the g function and I put 0 in and it always adds 1. So when I have g of 0, I'm going to get out 1. So as an ordered pair, that'd be 0 comma 1. Now once we get down here, we can't really do ordered pairs anymore because we're doing multiple functions. So like this one here, it wants me to input 2 into the f function, which squares things and then adds 3. And over here, I'm going to input 1 into the g function, which just adds 1. Then once I have those two numbers, I'm going to add them up. So again, if we just follow careful order of operations here, 2 squared is 4, plus 3 is 7, 8, 9. And again, I can't really write that one as an ordered pair anymore, because I use 2 different functions and 2 different inputs, so it doesn't make sense to do it anymore. This one is very similar to the last, so we're going to go to the g function, input -1, and it adds 1. Then I'm going to go to the f function, and I'm going to input 1, which is squared, and then I add 3, and then once I have those two answers, I'll add them up. So over here, negative 1 and 1 is 0. 1 squared is 1, plus 3 is 4. We're going to skip these last 4. I wouldn't worry about them. And if we look over here, we just have a little multiple choice. So here is our new f function. I'm going to input 5. So f of 5. In place of x, I'm going to put a 5. And basically just follow order of operations. Not doing anything with the f of 5. The f of 5 is just going to stay. So over here, I would square it for 25. I would multiply. And then we would subtract. So f of 5 is 10. So we would pick 10. And if I wanted to write this as an ordered pair, I could, where the x value is 5 and the y value put out is 10. Okay, so another example of that here, using this f function instead, if I were to input 3, in place of x, I would put 3, and then we just follow good order of operations. So negative 3 times 3 is negative 9, plus 1 is going to be negative 8. So we would pick B. If I wanted to write it as an ordered pair, we would do 3, comma negative 8, because I input 3 and it output negative 8. Now, last but not least, this one here is a little tricky, but I like it. So with my f function here, in place of x, I'm actually going to do x plus 1. So same thing over here. In place of x, I want to do x plus 1. But since I'm kind of inputting two things, I need to use parentheses. So we're not going to simplify this to a final answer. I don't think I can because I have an x involved, but I can simplify a little bit by distributing. And so I'd have 2x plus 2 minus 5. And then I can combine those like terms. And so we'll have 2x minus 3, but I can't go any more because they're not like terms. And so I'd pick A. Alrighty, let's take a look at 42. So it's just more of the same, except we're going to look at our functions in slightly a different way. And I'm going to leave a couple on this one for you guys to try. So if we look at the one on the left, we're looking at our graph. So this time they don't give me an equation for my function. They gave me this graph, which this graph is talking about the speed of a snail. So we got time and speed. And so if they're asking me to find f of 7, I'm inputting 7, or my x value is 7, which is always along the bottom. And so we'd go to 7, and then I basically just need to go find my graph, which it's all the way up here, which happens to be at 10. So it output 10, which what this means is, because my input was 7, and that's along the seconds, after 7 seconds, the snail is going 10 centimeters per minute. So the 7 is seconds, so 7 seconds go by. And the 10 is speed, so he was going 10 centimeters per minute, because that's, I mean, they're slow. So another one like that, right here, if I have f of 6, again, that's 6 seconds. So I'd go look for my graph, and it's not quite to 10, so I'm going to have to approximate a little bit, like maybe 9.9 or 9.8. I mean, there's no real right answer there. I'll go 9.8. And we would say the same thing. So at 6 seconds, snail is going 9.8 centimeters per minute. Now with the one next to it, or the one under it rather, they give me the description. So they said after 12 seconds, the snail was traveling 8 centimeters per minute. which I can see like 12 and then 8. We just have to put it in function notation. So we put our input inside the parentheses. Our input is our x value, or along the bottom, which is seconds, so 12. And then it output speed, and so we would say 8. And I'm going to leave the last 2 for you to try. Now over here on the table, we can also use a table to represent our function. So this is how many miles we travel, and this is how much money they charge, like Diner Dash or whatever it's called. So x is how many miles I travel. That's my input. So if my input is 3, it's going to output $28. So that means if I go 3 miles, it costs $28 for the delivery. Okay, so another one like that. If I input 1, so if I travel 1 mile, it will cost $14. So go 1 mile, it costs $14. And then we can go backwards as well. So if they tell me that the delivery charge for 5 miles is $42, well, yeah, it is. I can see that. But if I want to write it out in function notation, inside of f, into our function, we put the x value, or in this case, miles. And then it always outputs the price, which is $42. And again, I'm going to leave those bottom 2 for you to try. So I'm looking for 4 answers here. Boop, 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 those 2 on the graphy one and 2 on the table one. Good luck.